In this video, we'll be looking at doing these unit circle problems, finding exact values for angles using the unit circle without the unit circle diagram that we had in the previous example. So unfortunately, you're not just given that, and most of these will probably pop up in the non-calc, so you can't just put this in your notes either. So we need to be able to do this using our unit circle, and the method I use might be different to what you've learned, but this is the way I do it, where you want to find the reference angle first. So sine 150 degrees, I'll draw out a unit circle. Okay, start off here. We start from our positive x-axis, and I usually just draw like a quadrant like that. And now we want to measure sine 150 degrees. Now I know that starting from the positive x-axis, it'll be all the way through there, intersect here, and that'll be 150 degrees, right? Now I want to find the reference angle to that. The reference angle is basically whatever the closest, whatever angle the arc or the ray here makes with the nearest x-axis. The nearest x-axis in this case is 180 degrees, so the difference here, this angle, would be 30 degrees. So our reference angle works like this. We draw this across, and we're looking at 30 degrees. Why we've done that? Well, sine 150 is going to be equal to sine 30 degrees, that's our reference angle in the acute case. And is it positive or negative? Well, this is always positive in this quadrant, and sine 150 is positive, so we can just keep the same sign. So now sine 30 degrees. Sine 30 degrees, if we use our table from before, sine 30 is a half, okay? So the trick is just making it acute, finding it in quadrant 1, and then just putting in the exact value. Next one, cosine 315, draw out the unit circle. Okay, we need to go 315 degrees around, which I know is 45 degrees away from the nearest x-axis, which in this case is the positive x-axis. So I draw that in and I go, okay, that there is going to be 45 degrees. So I'm looking at my reference angle, which is over here, of 45 degrees. So straight away I go, this is equal to cosine 45 degrees. Now, cosine 45 degrees. Is cosine positive here? Cosine 315? It is. So therefore, we don't need to change the sign. So we've got our magnitude correct. Cosine 315 is equal to cosine 45, and they're both positive. Now we know that this is root 2 on 2. C, tan negative 210. So if I draw this as a unit circle, quadrant, okay, negative means it's going the other way. Okay, so let's let that load up. And we've got our diagram over here, hopefully loading up soon. There we go. Negative 210 means that I go around past 180, another 30 degrees until I get to this point here. So I know that the angle that makes the nearest x-axis is 30 degrees. Okay, so 30 degrees is this chunk here. Therefore, my reference angle in the acute is also 30 degrees. So I write this out and I say, I know this is equal to tan 30 degrees. Okay. Now, tangent negative 210, which is here, we know that, and I should write that as negative 210, we know this is a negative gradient, right? Whereas here it's positive. So we know that tan negative 210 degrees and tan 30 are the same magnitude, but we need to get the sign right. So we need to make this negative for it to work. So we need to go negative tan 30. We know this is equal to root 3 on 3, so it's negative root 3 on 3. There's our exact value. Let's have a look at this one, sine 270 degrees. I recommend pausing the video and having it go from D to F first, then pressing play when you're ready. So let's have a look at this one. Draw the arc, goes to here. Okay. And what's the reference angle to this? Well, it's going to be 90 degrees, and it's going to be negative, because the distance is 90 degrees from the either x-axis. So it's equal to sine 90 degrees, and we know that down here, sine is going to be negative, whereas up here it's going to be positive. So we need to go negative sine 90, which is equal to negative 1. Okay? Or you just know that that intersects the unit circle, and so it has to be negative 1 anyway. E, cosine negative 30 degrees, draw out a unit circle. And if you just know these, that's fine. You don't need to do this. This is negative 30 degrees. what does it make with the nearest x-axis? Well, it's 30 degrees, right? So our reference angle's over here. So we know this is equal to cosine 30 degrees. And is it positive or negative? Well, cosine here is positive, cosine here is positive, so we don't need to change the sign. So we can say that cosine negative 30 is equal to cosine 30, and therefore this is equal to cosine 30, which is root 3 on 2. Tan 120 degrees, draw out the unit circle, start from the positive x-axis, spin around until we get to here, 120 degrees. What's the distance between the nearest x-axis? We can see it's 60 degrees. So therefore, our reference angle is here, 60 degrees. So we can say tan 120 is equal to tan 60 in magnitude. And do we have to determine whether it's positive or negative? Well, here this is negative gradient, when here it's a positive gradient. So we need to make that negative, and we know that tan 60 is negative root 3. Now for these ones here, let's have a go at this one together, and then I want you to pause the video and have a go at H yourself. Now this is 540, so this is beyond 360 degrees. So if we draw a unit circle, what are we doing? We're going, starting from here, spinning until we hit 360 degrees, and we just keep going. So how far do we need to go? Well, we know that 360 plus another 180 degrees makes 540. So there, it's 540 degrees. Okay, so we've hit that 180 degree mark. So we can just simply subtract off 360 degrees. We know that's going to be exactly the same. So sine 180 degrees, which is equal to negative sine 0 degrees, which we know is just 0 anyway. That's our answer to that one. We're going to have a go at this one now. Cosine 690. So let's just minus off 360 off that and see what we get. So that's going to be cosine 330. So this is going to be exactly the same value. So we have to look for cosine 330. We know this is the same as cosine 30 degrees because this bit here is 330, 30 degrees, and it's the same sign. So we can say, and I think we've had one of these before. Yeah, the one above is root 3 on 2. Okay, root 3 on 2. Now there's a few other ways of doing this. This is the way I like to do it, where we find the nearest, the angle to the closest x-axis, find the reference angle in quadrant 1, and then just use our table from above, but hopefully just your memory now, to solve. Okay, hope you enjoyed the video.